Hello, and thank you for joining us for Hyliion's third quarter 2025 earnings call. I'm joined today by our CFO, Jon Panzer. We're excited to share the significant progress we've made this quarter with the KARNO Power Module, along with the growing customer interest and market demand we're seeing for our technology. I'm pleased to share that the KARNO Power Module is now performing at a level that meets the key performance needs of our early customers. On our previous calls, we outlined several system enhancements that were in development, and I'm happy to share that those improvements have delivered meaningful gains across multiple performance areas. Throughout today's call, we'll review the performance metrics that matter most to our customers, including dispatchable power, reliability, emissions, and outline where we stand on each as we begin entering the next phase of KARNO deployments. I'd like to start by directing your attention to the slides accompanying today's presentation. The first slide outlines the key performance targets that our early customers need and where we now stand against each of those benchmarks. As you'll see, we've reached a performance level that meets or exceeds these thresholds. I'll start with the power output and efficiency, which is where we saw the most significant improvement this quarter. As we shared previously, the regen component of the KARNO core had been underperforming relative to our expectations. Over the past few months, we implemented the redesigned regen, and as anticipated, it delivered a material improvement in both power and efficiency. We are now achieving more than 200 kilowatts of mechanical power and north of 150 kilowatts of electrical power generation, meaning the system now meets the power needs of our initial customers. In the months ahead, we'll continue to implement small design refinements that are expected to further improve electrical output and overall system performance. These refinements are anticipated to bring electrical power generation to 200 kilowatts as we move into commercialization next year. Next, I'd like to highlight an important regulatory milestone that was achieved this quarter. Through our internal testing, we have confirmed that the KARNO Power Module can meet the extremely stringent air quality standards established by California's South Coast Air Quality Management District, which are among the toughest in the nation. While running on natural gas, the system achieved NOx levels below 2.5 parts per million and carbon monoxide in the low single digits parts per million, performance that far exceeds compliance thresholds and was achieved without the use of any exhaust after treatment. In addition, we are pleased that the U.S. Environmental Protection Agency recognized the advanced nature of our technology and determined that the KARNO Power Module is not classified as an internal combustion engine under existing federal regulations. This determination means that our system will not require traditional federal engine permitting and will instead only be subject to local air district authority oversight. It's a major step forward that removes a significant regulatory hurdle and allows customers to move more quickly towards deployment, as most other technologies are subject to both federal and local air permitting requirements. Now shifting to reliability. This quarter, we reached another significant milestone with one of our KARNO Power Modules completing more than 100 days of operational testing on a customer unit without any unplanned hardware-related downtime. While the system wasn't operating continuously during that period, it underwent extensive runtime across a wide range of load conditions and hundreds of start-stop cycles. These results give us a high degree of confidence in the underlying architecture and its ability to deliver the low-maintenance operations that customers value. Finally, we demonstrated the KARNO Power Module's ability to seamlessly switch between fuels while operating under load. In a recent demonstration, the power module alternated between natural gas and propane without any interruption in power delivery, automatically adjusting performance in real time. This capability highlights the true fuel flexibility of the KARNO architecture and its ability to switch fuels while in operation without impacting performance. As a reminder, the KARNO technology will be capable of operating on more than 20 different fuel types, including natural gas, propane, diesel, hydrogen, ammonia, JP8, and many others, providing customers with unmatched adaptability across energy sources. During the quarter, we deployed a power module to begin our UL certification process, which is an important step that many of our customers expect before large-scale commercial deployments can begin. I'm pleased to report that the UL process for the KARNO Power Module is progressing well and is on track for completion in the coming months in parallel with deployment of systems to field trial locations. We've completed and passed UL testing requirements for the linear electric motor, and notably, it passed every test on the first attempt. Our UL certifier stated that this was the first time that he had ever seen a component achieve full compliance on the initial try, which speaks to the robustness of the design and the tremendous work of our engineering team. During the build of the UL Power Module, our team identified several opportunities to enhance the design of both the high and low voltage assemblies. We made the decision to implement those updates immediately rather than to deploy the units and retrofit them later. While that choice caused some short-term adjustments to our delivery schedule, it ensures customers receive the most compliant and reliable product from the start. Next, I'd like to share the latest with our customer deployment plans. Similar to the approach we previously shared, some customer units will first operate at our Cincinnati and Austin facilities in a controlled environment where we are doing integration and demonstrations requested by the customer. We presently have multiple customer units in this structure in Cincinnati, with more planned before year-end. From there, these systems will be transitioned to customer sites for permanent operation. Other units will go directly to customer sites. We initially projected 10 early adopter units, followed by design refinements as needed based on customer feedback and system performance. We're currently building these units and aligning deliveries with customer schedules and their timing needs. These deliveries are expected to be made during the remainder of this year and in the early part of 2026. One of our early adopter customers has experienced delays in their project build-out and has shifted their project timeline into 2026. As a result, we plan to utilize a couple of these early units as demonstration systems for additional customer showcase opportunities. We'll deploy these units at various customer sites with a particular focus on data center applications and third-party demonstration centers. This strategy will help us gather further product validation and increase our visibility. We expect deployments to continue at a steady pace as we progress towards full product commercialization in 2026, demonstrating the KARNO Power Module's operational performance, reliability, and scalable production capacity. Beyond that, while we anticipate continued growth in R&D-related revenue, we are not yet providing detailed guidance for 2026. Customer interest in the KARNO Power Module remains very strong, and we continue to introduce new customers to the technology every month. These customers are not only seeking reliable power generation capacity, but also the differentiated attributes that set the KARNO system apart, including its ability to operate on multiple fuel types, improved resiliency, power density, low maintenance design, and high efficiency. To date, we've executed non-binding letters of intent with customers representing nearly 500 KARNO cores. Based on current demand, we anticipate being supply constrained for the years ahead as interest in the system continues to grow across multiple sectors. We're also deepening our engagement with the U.S. military as they explore broader use cases where energy security and reliability are mission critical. As part of our existing R&D contract with the Navy, we plan to deliver additional KARNO Power Modules and cores in 2026 for specialized testing required for shipboard use. Our team recently visited the first autonomous Navy vessel that will be powered by KARNO cores. That ship is currently undergoing sea trials and is planned to be outfitted with its initial KARNO units in 2026. The ship is designed with numerous engine bays and is capable of housing multiple megawatts worth of KARNO cores for that ship's power needs. This is an especially exciting program given the Navy's significant power requirements and the unique advantages the KARNO system offers in delivering efficient and low-maintenance onboard power with an excellent thermal and acoustic footprint. Next, I'd like to share an exciting update in the nuclear space. Hyliion has engaged in an exploratory agreement with one of the leading organizations in the small modular reactor, or SMR, sector to evaluate how our KARNO technology can be paired with next-generation nuclear systems. SMRs generate heat that is traditionally converted to electricity through a steam turbine. Since the KARNO power module's fuel source is heat, we're exploring the potential of replacing the steam turbine with a KARNO core to generate electricity more efficiently. While this collaboration represents a longer-term opportunity, we believe it is an important step in exploring now, given the growing interest and investment we're seeing in the nuclear energy space. Lastly, I'd like to touch on some important developments we're seeing in the data center space. NVIDIA recently published a technical report outlining that the next generation of data centers, particularly those supporting AI workloads, will increasingly adopt 800-volt DC architectures to improve efficiency, reduce conversion losses, and enable more scalable power distribution. This shift aligns directly with one of Hyliion's key advantages. The KARNO power module native output is 800 volts DC. While other technologies will require additional and costly conversion equipment to connect to these high-voltage systems, the KARNO system's design allows for direct integration. This positions Hyliion as a natural fit for the evolving power architecture of modern data center and AI infrastructure. Now, shifting to our capacity for the years ahead, the pace of deployments will be guided by insights gained from the initial units as we continue to fine-tune system performance and ensure consistent reliability. At the same time, our production capacity continues to expand as we transition more activities from our R&D facility in Cincinnati to our larger manufacturing facility in Austin. We now operate roughly 30 additive manufacturing machines across 3 generations of printer technology. Our current focus is on optimizing these existing systems for higher throughput while continuing to add additional machines to support growing demand. To help lead this next phase of growth, we've recently welcomed Daryl Preble as Vice President of Operations. Daryl brings extensive experience from the energy sector with a proven record of building scalable manufacturing programs and driving operational excellence, which he'll be responsible for at Hyliion. Prior to joining, he held senior leadership roles at Cummins and Husky Technologies. I'd also like to share some updates on the supply chain front. This year, we've been focusing on expanding and qualifying new suppliers to support future production scale-up. As part of that effort, I want to highlight one supply chain challenge we're actively managing. Like many U.S. manufacturers, we're experiencing challenges in sourcing the high-strength magnets out of China that are used in our linear electric motor. At present, we have sufficient inventories to support operations through the next couple of quarters, and our team is actively pursuing multiple alternative sourcing strategies. That said, the broader supply environment for these magnets remains uncertain, and we're continuing to monitor it closely to mitigate any potential impact on our production schedule. To wrap up, we're very encouraged by the progress we made so far in 2025 and the strong position we're in for the months ahead. We're excited to expand our customer deliveries and transitioning the KARNO power module into real-world applications. As a reminder, from our last call, we shared the KARNO power module and its supporting infrastructure will receive a 30% tax credit. This incentive will help accelerate adoption and support our commercial ramp-up over the coming years, as it remains in effect for the next decade. With that, I'll turn the call over to John for the financial update.
Thank you, Thomas, and good morning, everyone. In the third quarter, we recorded revenue of $800,000 from research and development services related to our contracts with the Office of Naval Research. Cost of sales was also approximately $800,000, resulting in a small gross loss. In the third quarter of 2024, we recorded no revenue or cost of sales. R&D services revenue reflects both the sale of KARNO cores and related components to the U.S. Navy, the work we perform to test and validate these units, and other development work. Operating expenses for the third quarter were $15.3 million, compared to $14.2 million in the third quarter of 2024. The increase was mostly related to higher research and development costs and lower gains from asset sales in the powertrain exit and termination line. The increase in R&D work reflects the more rapid pace of development and growth in the production of additive components. SG&A expenses were $5.2 million, down about $500,000 compared to the third quarter of 2024, and due primarily to lower facilities and insurance costs, partly offset by a small increase in labor costs. We recorded $2 million of interest income during the third quarter, down from $3 million in the prior year quarter due to a lower level of investments and lower interest rates this year. Our total net loss in the third quarter was $13.3 million, up from $11.2 million in the third quarter of 2024, but about flat with what we recorded in the second quarter of this year. Year to date, we recorded revenue of nearly $2.8 million, all from R&D services, and gross profit of $96,000. We recorded no revenue or gross profit in the same period in 2024. Year to date operating expenses were $50.7 million, compared to $47.2 million in the first three quarters of 2024. The increase is related to higher R&D expenses this year, partly offset by lower SG&A and powertrain exit and termination expenses compared to the same period in 2024. Net loss year to date was $44 million, compared to $37.7 million last year. Turning to our cash and investment position, we spent $20.6 million during the third quarter and $55 million this year to date. Year to date capital spending was $22 million and consisted primarily of additive printing machines and related equipment, along with facility investments to support printer operations. Cash from asset sales year to date in 2025 was $1.2 million. We finished the third quarter with $164.7 million of cash and short and long-term investments on our balance sheet. Throughout this year, we forecasted total 2025 cash expenditures of $65 million, including equipment financing of $10 million to offset part of this year's capital investments, leading to a year-end cash and investment balance of approximately $155 million. At this time, the timing of equipment financing is uncertain, with the possibility it may shift into 2026 or end up being somewhat less than $10 million, depending on the decisions we make related to timing and available terms. R&D services revenue has ramped up a little slower than we expected, partly due to a decision to defer delivery of some of the early deployment units into 2026 based on the timing needed by the U.S. Navy. Therefore, full year 2025 revenue will likely be approximately $4 million. As Thomas noted earlier, we expect that KARNO commercialization will occur in 2026, at which time we will begin recognizing revenue from KARNO system sales. We continue to expect that the capital we have on hand today will be sufficient to carry us through commercialization of the KARNO Power Module. Looking ahead, we anticipate that additional capital will eventually be required to support production growth, particularly for the purchase of additional additive manufacturing equipment. However, with approximately $165 million in cash and investments as of the end of the quarter, we are well positioned to be deliberate and opportunistic in determining the timing and structure of a capital raise. Now, I'll turn the call back over to Thomas.
As we wrap up, I want to leave you with three key takeaways. First, the KARNO Power Module is now performing at a level our initial customers require. This marks a major step forward for the product and gives us confidence as we begin broader customer deployments. Second, customer demand continues to strengthen. We have nearly 500 units under non-binding LOIs, and the newly established 30% investment tax credit further enhances the economics for our customers adopting KARNO systems. Together, these factors create a strong momentum heading into next year. And third, we're aligning with where the world's energy needs are going. From NVIDIA's planned move towards 800-volt DC architectures in data centers to our exploration of pairing the KARNO technology with next-generation nuclear systems, our technology is uniquely positioned to serve both near-term and long-term power needs. These advancements show that we're moving from development to deployment, turning the KARNO power module into a real-world solution for customers who need reliable distributed power. I'd now like to hand the call back over to the operator to begin Q&A.
At this time, I would like to remind everyone, in order to ask a question, press star, then the number one on your telephone keypad. We'll pause for just a moment to compile the Q&A roster. Your first question comes from Ted Jackson with Northland.
Thanks. Hey, Thomas. Hey, John. How are you?
Doing well, thanks.
Great, thanks.
So I got, 3 or 4 questions. The first one is the customer that has shifted its, I guess you would call it acceptance of, the initial KARNO units from 25 into 26. I mean, not that big of a deal. Could you just talk maybe what vertical is that customer in?
Yeah, so this is the Navy. And so as we highlighted on today's call, exciting news is that ship is now in the water, in the ocean, going through sea trials. And then we're scheduled to now be installed into the ship in 2026. And so that's why what we also wanted to highlight on today's call is it's not beneficial for us to build up those assets and then just have them sit waiting to actually be deployed into the ship. And so what we're going to do is we're going to take some of those and we're actually going to make them demonstration units that we're going to bring out to data centers, to some third-party validation sites, and actually utilize those assets to showcase the technology there, get more customer momentum growing, but then still be able to meet the demands of the Navy in getting those units into a ship in 26.
And then that ship, that's the unmanned ship that they're like. I mean, there's been a lot of press about the development of that ship, but that's what it is, correct? The kind of this, next generation sort of, crewless.
That's correct. And Josh and I and some of our team actually got a chance to go board the ship this past quarter, and it's unbelievably neat. It's really designed for weaponry on board and then fuel and engines to move the ship around. So very different than conventional Navy ships where you usually have to have sleeping quarters and a cafeteria and medical, all those things that personnel need. The ship has none of that. It's the hull of the ship. It's fuel storage. It's a handful of engine bays that we can deploy multiple megawatts of KARNOs into. And then the deck of the ship is designed where they can mount different types of weapons on board. And the goal of the ship is it gets deployed, and then it will be out in the ocean for a long time prior to coming back to dock. And that's one of the key drivers why the Navy was so excited about our technology, is because if you think about like a diesel engine that a ship is normally powered by, that requires every few hundred hours you need to do an oil change. Well, if there's no one on board, there's no one to do that maintenance. And that's where our low maintenance design really matches what they needed out of an engine.
I've seen pictures of it. It's a pretty cool looking product or system.
We're excited.
Then the next question for me, going into kind of the testing and such, is on slide 3, I saw that you had a couple of KARNO units sitting in the parking lot going through your testing phase. I mean, is that what I'm seeing there? Is that you have, when I came out and visited, you had 1 out there, now you have 2 out there. I mean, you mean something that picture as itself is an indication of progress with regards to you getting systems and going through those initial runs for your end customers?
That's correct. So we've got a couple of customer assets in operation at the facility. We also have a couple of our own assets in operation at the facility. So you're absolutely correct. And that was one of the reasons why we put that photo in there, just to show that we are building these systems. We're getting them out there. As we highlighted on today's call, one of the next big phases here we're working on is getting that UL certification. So we're going through that testing now. And then once we have that, then that really enables us to start getting these assets out to customer sites.
When do you think you'll have all the UL testing completed?
Yeah, we're talking, in the next couple of months here, we'll have that completed. And as we highlighted on today's call, so there's a couple of different phases of UL, right? So for instance, the linear electric motor needs to be certified, the battery needs to be certified, and then the whole power module itself needs certification. So one of the big milestones we hit coming into today's call was we were able to achieve the certification around the linear electric motor. So we went through that testing. We got the approval there, which, as we shared, I mean, the big accomplishment where we actually passed it on the very first attempt of doing it, which, as our certifier said, he had never seen something pass on day one of testing, which was great to see.
Congrats on that. I have a few more. I'm going to ask one more, and then if I need to, I'll come back in line. And that is on the regen rebuild. You commented yourself, the initial systems, and this is not a surprise, don't have that component in it. That it's not required for your customers, and it's an easy swap out. Have you, at this point, taken that new component and started putting it in units and doing any testing with it? And is that just for yourself, or are you doing that, and we'll go into some of the initial beta units?
Yeah, so both in our system, and then also it's now going into customer assets as well. So maybe just to step back, in past quarters, we saw performance deficiency with the regen, and we were working on depowdering and new architecture, new design of that part. Over the last quarter, we implemented that part into our own asset. We saw a step change in performance out of the system. So that was great to see. And that really highlighted, or brought forward what we shared on today's call, which is we've now gotten the performance to a point where we believe we're meeting the needs of the customer. So for instance, all of our early units that are going out to customers only require up to about 150 kilowatts of power generation. We're now exceeding that. We're now north of 150 kilowatts. So our thought is, let's move forward. Let's go ahead with the design as is, get units out into the field. And then as we near commercialization, there are some small areas that we want to continue to improve. So we're seeing some heat leakage through the piston. We're seeing some heat leakage through the cylinder wall, a sleeve that goes in there. So minor changes like changing the material of that component. So we're going through some of those changes so that as we get into commercialization, or as we enter commercialization, we plan to be at the full 200 kilowatts of power output of the system.
Well, that's why you go through beta, isn't it, to find those things and correct them. So I will step out of line, and I might jump back in later. Thanks.
Great.
Your next question comes from Sean Milligan with Needham.
Hey, Thomas. Hey, John. Thank you for
the
time this morning.
Morning.
Just a quick question on your pipeline. The 500 units that you have in LOI, you're going to be delivering some units next year to those customers. I'm curious about the timing you expect those customers to then test those units at their own operations, and sort of the conversion from LOI to purchase order, maybe what your expectations are in timing there.
Sure. So even before we get the first asset out into their operations, some of the quantity of units will move from LOI into a firm agreement. And then from there, it'll be how do we continue to work through that backlog of the additional units on the LOI, which I think to your question is, how long do they need to test it? Which we're hearing in the 6 to 9 months is kind of the rough time frame that customers want to run the asset, experience it, and then from there they believe they'll have the confidence in the performance to keep going forward. It varies between customers. Some customers are saying, let's do one unit right out of the gate. Others are saying, let's do multiple units right out of the gate. But overarching, the message is there's a lot of demand in this product, and the demand is continuing to grow. Even tomorrow, we have another new data center customer coming in that we're having great discussions with. And so we're continuing to build that customer interest. And as we shared today, we foresee that we will have enough demand in this product for years ahead that will actually be supply constrained as opposed to demand constrained.
That's great. Yeah. And then the other question was around the 500 units in LOI. Can you give any context around how many customers that maybe represents, and then sort of the timing of those? I think those date back to even 2024, first half of this year, but maybe how your discussions have expanded, sort of in terms of numbers of different opportunities you're now seeing in your pipeline. Just trying to understand how the pipeline's progressing as you're kind of moving KARNO forward here.
Sure. So, just kind of rough numbers, I believe it's in the dozens of customers, not in the hundreds of customers that we signed LOIs with. We are in discussions with even more than that. Not all discussions go to an LOI. Some discussions go to, okay, great, we like the technology, we want to see it in operation at other people's sites before we move forward with making a commitment. So, with all that, how has the market landscape evolved? I would say initially we were seeing a lot of interest from the military, a lot of interest from EV charging. We've actually seen some sectors that have popped up that have become even larger than those. So the data center space, seeing a ton of interest there. Data centers are just power constrained, right? That's their number one issue when they go to build out a new data center. They talk to the utility. Usually the answer is there's not enough power available. And so the data centers have really shifted to moving to make your own electricity, on-site power generation, which that's exactly what our technology is. Even as we highlighted in today's call, NVIDIA has come out and expressed that they see the future of data centers in the years ahead here actually shifting to an 800-volt DC architecture, which that is the architecture of the KARNO. We produced 800-volt DC natively. So we think we can fit perfectly into that. And then we've also seen just a growing demand on the commercial facility side of things. So the driver there is really, can you produce your own electricity for cheaper than you could buy electricity from the grid? So I'd say data centers, commercial applications are growing. And then the work with the Navy we've been doing has been going really well to a point where they've actually pulled in other branches of the military that we're now starting to work with as well.
Okay. And then the last question is around sort of manufacturing scale up. So if you go back to the first part of this year, you had the powdering issues, which you've addressed. And then also, I think you had some outsourced, you had outsourced product manufacturing, which you brought back in-house. And it sounds like the manufacturing side today, you're kind of honing in on design and feel comfortable with where you are. But I'm more curious about your ability to scale in the future. So, the confidence in coming to a systematic manufacturing process, the ability to scale up printers, and then just anything you need to do in-house there. And I think you brought up magnets, but obviously a lot of these award potential on the data center side specifically is very large. So just the ability to source materials. I just wanted to get your big picture thoughts there for Hyliion moving forward.
Sure. So I'll first start with the challenges we were facing. So we had outsourced production of the electric motor. We pulled that in-house, as you highlighted. And then we were having issues with the regen, the depowdering. We believe we've gotten our arms around that as well. So as we did this past quarter, we leaned in and said, yeah, manufacturing is going to become a big part of the story ahead. That's why we hired Daryl Preble to come in and lead operations for us. He's built out manufacturing facilities and distribution facilities for Cummins and Husky in the past. So this is not an unknown journey to him, which is great. And then as we look at the phase ahead here, I think one of the big areas of focus is going to be how do we continue to get more and more out of the additive manufacturing machines. So we've got about 30 machines installed so far. We've got in total about 36 roughly that we've ordered. So still a few more to be delivered here. And then from there, one of the focus areas is going to be keep getting more and more out of the machine. So we know that we're not operating them at their fastest parameters, at the greatest throughput. That takes some just work to get them to those faster throughputs. So that'll be our next phase. And then from there, we'll look to continue to expand the number of printers we have and buy more assets, and that'll be how we scale volume. So the reason that is really key to the story is we actually expect that we're going to slow down our capital expenditures. The goal right now is not just keep buying more machines. The goal is actually going to shift to let's keep getting more and more out of the existing machines we already have. And then as John highlighted, then there will be another phase where, okay, let's continue to expand manufacturing and buy more assets.
Great. Thank you so much for the time.
Your next question is from Ted Jackson with Northland.
Thanks. Hey, I wanted to circle back. You made a comment about, and honestly, I was taking notes. I missed what you'd said, but that you had a bit of delay in delivery or development because you decided to go for work with what was it, that 800 kilowatt? Is that what could you sort of could you go through that again with what you said in your prepared remarks?
Yeah, absolutely. So as we were putting together the UL system, we saw some areas of opportunity that we could improve, both high voltage, low voltage. And so we decided to do those changes prior to going through UL certification, because once you certify it, it's much more difficult to go make changes after that. You have to go back through another recertification process. So what we decided was, why don't we go ahead and roll those improvements, those changes in now and get those done, which has been done. They're in the, to go back to your reference of the photo of the parking lot, they're incorporated into that UL system that's out there. So we made those changes. Now, that did add some time to the schedule. And so that was just a strategic decision we made of let's get those rolled in and go through the UL certification process with those, as opposed to have to do an alteration or change down the road.
Okay. And no, that's kind of the other question I had got asked. So thanks.
There are no further questions at this time. I will now turn the call back to Thomas Healy for any closing remarks.
Great. And we actually had a couple of questions come in that Greg will read off for us as well.
Excuse me. Thomas, can you share more about why you see Carno as a good fit with nuclear and what timeline you envision for developing a solution in that space?
So today's call is the first time we've really talked about nuclear, but the reason we wanted to is because it really highlights the versatility of the Carno system. So as we've shared in the past, I mean, the Carno is a heat-powered generator. And so if you look at nuclear, all nuclear does is it makes heat. And then conventionally, nuclear SMRs will use steam turbines to take that heat and convert it into electricity. And so we started engaging with an organization in the SMR space, in the nuclear space, who were looking at actually replacing that steam turbine with a Carno. And we're seeing that we should be able to produce electricity more efficiently than even a steam turbine can. And so why that's important is, we're seeing that there's a lot of interest and a lot of momentum in the nuclear space. It's not happening tomorrow. This is still a ways out as to when nuclear and SMR will be deployed. But we think it's important to get our name into that discussion now, because a lot of these companies are in the R&D development phase and could select us as their way to produce the electricity as opposed to using a steam turbine.
You mentioned on today's call that NVIDIA has highlighted a new electrical architecture for data centers. Can you elaborate on how this matches Hyliion's existing architecture?
So data centers today are a lower voltage architecture. They are DC power, but they're in the 50, I believe it's about 58-volt DC architecture. And NVIDIA came out with a report, a white paper that said they see the future actually moving to 800-volt DC power. Reason being is that as computers become more powerful, they consume more electricity. And when you just start scaling up, you end up consuming a lot of capital and just even the cost of copper to move that electricity around. So if you move to a higher voltage architecture like this 800 volt that we're at, you can reduce how much copper you need. You can reduce some of the other components and make the whole data center architecture more efficient and less costly. And so that's where we were excited to see this because it matches us perfectly. We make 800 volt DC power natively. So if that's where data centers head and they start adopting other technologies like the grid, 480 volt AC architecture, are going to require other components, other inverters or converters to move to that 800 volt DC versus we'd be able to couple without those components. So it just aligns well with our vision and structure of what the product outputs and where data centers are heading. So with that, I believe that concludes the questions that we had come in. So on a closing note, appreciate everyone joining today's call. As we highlighted, we're pleased with some of the key metrics we've hit on the performance side of things. We're seeing growing customer demand, and we're excited about not only being a solution for the near term here, but also some of these future opportunities we discussed as well. So with that, we'll talk again next quarter. But in the meantime, I do encourage listeners to follow us on our social media channels. Also, follow the press releases we release as we'll be sharing more throughout the quarter on those channels. Thank you for listening.
This concludes today's conference call. Thank you for participating. You may now disconnect.